Alright guys, here's another little video clip that's a reminder of why I'm doing all this work and get a final flying aircraft to get out there and really enjoy. The Kitfox is such an amazingly fun airplane to fly. This is my Model 5. Had a good day out flying on the river the other day. But enjoy this clip and then we'll jump back into the electrical system on my new Kitfox 7 and how to wire up the avionics. You guys have seen the clips about how I did this panel. I did add a little decal on there. And then on the far side, let's go around the other side actually, I added the USB port. And that is this unit here from Guardian Avionics. They're the ones that supply the in-panel iPad mount. So iPad mount's really awesome, guys. This is really the finest one you're gonna find. I'll go through the operation of putting the pad in and out, but it has a charge cable right here. It's got a 90-degree turn on it. So while your iPad's in here, it is charging. And there's ducting actually built into this case, and there's a little scroll fan that's also run by this power supply. And then it's going to provide power to the iPad, to the fan, and then also it has a USB outlet on the front, which can power another device. So you can go phone, camera, whatever you want to do there. See right above that, still need to put some screws in it, but this is the ELT remote control. This ELT unit I got, it's the ACK, and it came with this little box here. I didn't know this was going to be part of it, but this is an audio alarm that lets you know when your ELT is going off. I went ahead and put that in the series. I still, again, have to clean up all these extra lengths of cable. But that cable runs back. I just finished up mounting the ELT back behind the passenger seat here. So I went ahead and used some Adele clamps. I had to extend, we'll make a little bracket there to extend the bottom left corner. This could be an externally mounted antenna. It is weatherproof for that. But I went ahead and just made a little bracket for it. And you can see that where it is, you can whip it around pretty good and it doesn't hit anything. I'm gonna start this clip by saying how many takes it takes in order to get these little tutorial monologues done. I hope you guys appreciate the effort that goes into it, because I talk through them and then I realize that I just talked for 10 minutes about something that you're not going to want to watch for 10 minutes. So let me accelerate what I was just talking about. Where I started on this wiring project is reading the manuals and pulling the most pertinent documents out and putting them on the wall. On the left, you got the Autopilot schematic, the Grand Rapids EFIS schematic, and the radio schematic. Those are my three main components in the panel right now. I've got the AEM engine monitor coming, but it's already pre-wired. So I'm gonna go ahead and explain a couple things. The Autopilot's where I started, and basically what I went through is these represent the pin connector on the Autopilot. I went through and make sure all the wires were actually plugged into those pin numbers so that this diagram would match what they sent me, and it all matched just fine. I then took each wire from the connector that goes and plugs into the Autopilot, and I labeled it with a shrink wrap label maker, which is basic label maker, Dymo, using shrink wrap tape. It prints on there, and then it's just your basic shrink wrap, like, you know, like this stuff. You just heat it with a heat gun, and it shrinks down nice and tight. An example of that would be right there. PIC headset. Shrunk on there, labeled. Every wire in this airplane is going to be labeled. But basically what I've determined is where each wire is going to go. I know how I set up the panel as far as the switches. So let me just show you real quick how that worked, because it worked out pretty cool. So here's the wiring bundle for both servos. It's cut to length, so you can see each one of these. I haven't shrunk them yet because I want them to position the shrink wrap so that I can see it once I get all the wires installed. But see that one says roll servo engage. So each one of these wires is labeled, and they will run through a basically a nylon sock, this stuff, when it's all done, and that will run up to the panel. Now, the functionality of the Autopilot, there's a blue wire that's going to run over here to the control stick, which I'm not going to use right off the get-go, but I'm going to leave it there in case I ever want to upgrade. As you know, my stiff grips only have one button on them, and that's for transmitting. I'm working Not very much, but it's in the back, up on the back burner. A new top that has a trim switch, push to talk, and an autopilot engage disengage button. So it'll be a completely new top to the grip. So that's something I've been wanting to finish up, but it's just taken a long time to get to it. So in the meantime, the other options or requirements for the autopilot is one, to have a power switch. So this will be the power switch. You'll turn that on, and that will supply power to the autopilot so that it will work. Then you can do either 1 or 2 buttons to engage it. If you did 1 button to engage it, when you push that button, you're going to engage the altitude and the heading at the same time. And there's no way to then turn off one or the other than this blue cancellation wire, which actually only turns off the roll. So if I had 1 button on the panel, I turn on the power, I hit the engage button, it would sync up altitude and heading, and then I could click this button on the cyclic, or I'm sorry, on the stick, helicopter guy, and it would disengage roll, and I'd be just in altitude mode. And then if I wanted to come back to heading mode, I'd have to hit the engage button, disengage both, and then hit it again and engage. It seemed complicated to me, so I decided not to use the disengage button for now. Instead, I put in 2 momentary buttons. So I'll turn on the power. The bottom will be for altitude, the top for heading, and you'll just hit whichever one you want to engage. And if you want to disengage both, you can either turn off the power or you can hit the 2 buttons again and they'll disengage. So this will be engage, disengage for altitude and heading. So I had to add 2 holes to my panel, but they're all in line, and the throttle is going to be right here, and so I can actually hit the button while having my hand on the throttle with my thumb. So that was the thought behind putting them right there. It's very ergonomic. Have a hand on the throttle, you're coming into land, you pull your power back, turn your autopilot off, start flying it. So again, I don't know how often I'll use this autopilot, but I just want to explain what I did with their switchology. You can basically choose how you want to do it. I started with the Garmin GTR 200B radio. This was ordered from Aircraft Spruce. They did have the option to order a wiring harness. It comes in a fixed 4-foot length, or you could order custom length wires, and you're either going to have not enough wire or it's going to be too much wire. It won't be specific to your install. So I decided to tackle doing it myself. So with that, it came with the plug and the pins, and that's it. So I ordered the headset jacks, and basically they're for the mic plug. You know, your headset has 2 plugs, the mic plug and then the headset plug. The mic plug is going to be a 2-conductor shielded wire, and the headset plug is going to be a 3-conductor shielded wire, and it can be 22 gauge. So I had some 3-conductor shielded wire, so I've done the headset side, and I'm waiting for the 2-conductor shielded wire to arrive that I ordered to do the mic side. Then you'll also use a 1-conductor shielded wire for the push to talk button. Now the connector pinout information, you start with that. I went through and decided what I actually needed. And there's an explanation in the manual for what a lot of these are, like the CAN bus low and high. I won't be using that because that is a way for the Garmin G3 to talk to the radio. And I don't have a Garmin G3, so I don't need that. Like receiver audio out, I don't have that. Interlock is something you're going to use if you have 2 radios and you need to make sure that when you transmit on one, it doesn't mess with the other one. So a lot of the stuff I was able to eliminate, and then I went through, I've checked what I've actually already wired, and then the dashes show what I still need to wire. So power's 1, ground's 20, for example. Those are in and done. Here's what you're looking at and what I've been making. So these are the 3-conductor shielded wire that go to the headset jacks, and then this is your ground and your power, and that's as far as I've gotten on crimping those and putting them into the plug. I'm now waiting for more wire to show up to finish out the rest of these. That's about it, guys. So wiring is really just doing a lot of reading and planning. Now I'm going to take all these pages and the way I wire them, and then I'm going to create a schematic like this. And some of you guys have shared some really cool wiring schematics. Scott Noble had an amazing one. I don't know what program he used to do it, but it was so incredibly detailed. It was awesome. And I am going to use these blade style fuse buses, and I can explain in great detail why I decided to go this route, but I'm sure I'll get criticized for that. But this is, for me, this is going to be, I think, a really sweet setup. It's going to function. I might have done a clip on this already. There's nothing in this panel that if it was to pop a fuse would be detrimental to flight, other than, let's say, like a fuel pump. That's why I'll have a second one, and those will actually be wired to different buses. Problem with circuit breakers that I see is when a circuit breaker pops, it gives you a false sense of security that you can just pop it back in. Well, it popped for a reason. There's something wrong there. And if you pop it back in and it pops out again, you know, you look at any POH out there, and when that happens, you are to leave it popped the second time and don't use it. So you're only getting one more shot at it. But if it popped originally, there was something there that created an overload, and that needs to be addressed. So if a blade style fuse blows, that same problem existed, you just can't reset it. There's still a problem there. And so by the fuse blowing or circuit popping, it's telling you that you need to look at that wiring situation and find out what's going on there. So I don't really feel that it's necessary to be able to reset it in flight. I'd rather land, take a look at the circuit, find out why it popped to begin with. So that's my reasoning behind it. You guys have also asked about vertical power. It didn't make sense to me financially to do it. It's a very expensive unit, and I didn't see the direct advantage, and the ease of wiring didn't seem to be any easier than what I'm doing. And it didn't really provide any more simplicity to the system. It made it seem a lot more complicated. There's a lot more programming to do than there is installation. So I'll wire this and be done. That you're going to wire it, and then you're going to have to program a computer to talk to your Grand Rapids EFIS in order to monitor all that stuff. And really, it's a lot of it is because I'm not familiar with it and I don't have experience with it, and that's probably what factored into it most. So I'm more comfortable with old school style wiring. Not saying it's not a good system. I just decided not to go with it. And maybe in the future, some other build, maybe I'll look at it again. That's where we're at with wiring. Sorry that took so long to explain, but I just want you guys to know the process. Well, like with everything else, the time that it takes to commit to doing this, a lot of it's getting prepared to do it. It took me several days to wrap my head around getting started on the wiring, because you don't know where to start. You know, I bought a book about aircraft wiring, read it, and had just as many questions after reading that book on how to do stuff. So then went to the forums, asked a lot of questions, called a lot of friends who've just done this with their builds, and kind of took all that information and came up with my own design. This is by no means the only way to wire an aircraft. This is how I'm doing it. This is the way I have experience doing stuff and what I'm comfortable doing with the components that I decided to go with. Alright guys, so I got a bit of a mess here, but I want to explain how, first of all, why it's so long between videos. You can see this big mess on my table here, and then my wall with all these notes on the wall. So what I'm doing is I'm making the wire harnesses for the all the avionics. This one particularly is the Grand Rapids Horizon Horizon EFIS B connector, 25 pin D sub pin connector. So what I just wired in here, and I did make an error, so I got to change it, is the magnetometer. So this is your magnetometer. It weighs 0.25 pounds. It's going to go out on the wing, and because it goes on the wing, I put a connector on it, a Douch style connector, 3-pin, and I did that so that if I remove the wing, I can just disconnect the magnetometer. don't have wires to have to cut or anything. 3 wires coming out. You got a ground, the middle one is a power, and the outside one, the brown and white one, is a serial connector, or serial out from the magnetometer, and it's going to go into the EFIS, and that's what transmits the data. So there's your magnetometer. The other end of that, this is the connector that's going to connect at the wing. I made up this nice wire. It's got all 3 wires in there. Comes down and goes into this B connector for the EFIS. Now, how do you figure all that out? Where's this going? So what we do is we start out with the magnetometer pinout, and this is the basically a CAN bus style 9-pin connector that comes out of the magnetometer, and we're using the white and brown in pin 1, the white and red in pin 4, and the ground in pin 5. So we were just using 1, 4, and 5. That's it. The rest of those don't get used. So that's the wires coming out of it. So that was checked. Then we go down here to the 2 25-pin connectors that go into the EFIS. And we look through and see which one uses the magnetometer input, and it's on the B connector. So that's what I'm working on now. The B connector uses male, and the A connector uses female pins, and so you can't screw those up when you plug them in. So we go down here and we look for the magnetometer stuff. So we got magnetometer power, and that's what I screwed up. I put it in aux power, which doesn't make a bit of difference. They're both power, they're the same thing, but I'm going to keep it labeled. So I got to pull it out of 14 and put it into 12 to change the power. Then you have magnetometer serial, which is B10, and that will be where the brown and white wire goes, and our ground is in B13. So what does that B13, B12, B10, what does that mean? You come over here to your pen. This is what the back of the pen looks like. So reading from right to left, top row is 1, and you count all the way across to 13. Then you start over on the right, 14 across to 25. So in this case, we're going to use, well, we should have used B12, which would be the second pin in here for our power. And then we're going to use the magnetometer ground is going to be B13, so those 2 right next to it. And then we're going to use the serial data, which is B10. So we'll skip a pin, come over to this one right here. So the reason I wanted to show you this is because every single wire and everything you're putting together in the aircraft has to be done that way. So go over here and kind of the same thing with the radio. These are all the wires going into the radio harness. Finished this yesterday. So this is all your intercom and your transmit. So you got your pilot and co-pilot, headset and mic jacks, and push-to-talk transmit buttons all coming in here. You also have these 2 sets of wires, and this is going to be for audio in to the intercom from the EFIS in case you have an alert that you set. It'll give you an audible alert. The green wire is your data transfer, an RS-232, basically like a serial port. It's going to run between the horizon and the radio. So when you're on a moving map and it comes up to a frequency, or when you get near an airport, it will show the frequency and you can tap it and it will transmit it over to the radio and automatically tune that radio for you. So all those pins have to be identified. They've been identified on the radio side, and now I've got to take those ones that go into the EFIS and pen those out into the proper connector. There's your A and your B. So this is your A and B that I'm working with for that data to go into. ADS-B is going to go into there, radio connections, magnetometer connection. Here's your GPS, safe flight GPS. So this has got some wires right here that's going to go into there, all transmitting serial information to or from whatever peripheral device you have. So each one of those pins, none of this is done for you. I mean, you could have someone do it for you. Well, what's the fun in that? So each one of these has to be identified, mapped out. The length of the wire has to be measured based on how you're going to route it, and then the other end penned and put into the plug. All right, guys, so I just unpacked the entire engine electronic system from Brian at BD Turnkey Engines. He is a professional engine tuner, and he has worked with the AEM brand of products to come up with a complete system for the Yamaha Apex engine. This is an all aftermarket engine monitoring, engine control, be able to monitor and control the air-fuel mixture through fuel adjustments, and then also timing using a wideband O2 sensor. These are all the sensor packages here. We've got everything from an EGT module, inlet air temperature, ignition module, NOx sensing it has, oil temp, coolant temp, fuel pressure sensor, oil pressure sensor, and a gearbox temperature, so we can monitor the gearbox on T.L. Jenkins' gearbox. This is the engine monitor display. This is the last piece of my panel that I've been waiting for, so this is going to be installed very quickly here, probably today. And this is the bracket that I need to bend up to mount that into the panel. This is the AEM ECU, the Infinity Series 3. This is pre-programmed by Brian. He did a dyno run with the Apex and found the best air-fuel mixture ratios and mapping to load into this. So here's your factory ECU, and here's the new AEM ECU. AEM is a lot heavier, but what this allows us to do is completely control the fuel mapping and the timing of the engine using the wideband O2 sensor. So we'll be replacing this unit with this cool unit. It also has the ability to data log with a computer. So once it is in the aircraft running with my particular intake and exhaust, we can do some data logging. I can send that information to Brian. He can remotely program that, and we can get it dialed in perfectly. So a lot of guys have been going with the factory harness, sending it off to Ian, who does a great job. Matter of fact, when we show you a comparison, this is Ian's harness right here. He takes the factory wiring harness and turns it into, he takes everything away that you don't need, turns it into a nice harness, and that would be one way to go using the factory ECU. This one, however, is all brand new. Every single wire and connector in here is brand new. It is done very professionally. You can see everything's wrapped, finished real nicely. It uses all the same plugs that are on the Yamaha, so all these will plug right into ignition modules, coils, injectors, everything's already set up on there. And then all the sensors that I just mentioned, they have wires already pre-wired in. Yeah, so here's your relays, stuff like that. So all this has to be, I gotta find a home for all this stuff in the aircraft. I'm really impressed with the work, the packaging, the labeling, everything's really great. What we're doing with Brian is, this is the first one. And working with him, we're going to kind of create a directions or a manual on how to install this stuff. I'm a great person to use for that because I don't really know what I'm doing when it comes to setting all this up. So if I can do it, we can work through talking to him how to set everything up. Then we can get those directions laid out, and then you guys will be able to do this if I can do it. All right, thank you to Brian Dacus for getting me the new engine monitor screen sent out. Let's go and take a look at the finished panel. Obviously I haven't wired the EFIS yet, but I've got the iPad on the demo mode, and the power is to the engine monitor. All right guys, so it's time to mount up the engine. So mostly for mock-up purposes, for putting all the electronic components behind the firewall. And basically what I'm doing here is I'm looking at what kind of space I have between the engine and the firewall, and then what I can do as far as mounting components on the inside of the firewall, outside of the firewall, where the battery's going to go, the contactors, stuff like that. So I position the Infinity Series 3 ECU, which is this guy right here, right in the center of the firewall. And the reason I did that, one is it fits real nice right there, and two, there's this port right here that if you take this cap off, It's a USB plug-in. And that can go to a computer, and then you can data log while your engine's running. The power bus is going to be on that side. There'll be a second one, a smaller one that's going to be essential bus will be right there. This is what I have to wire for that. So that's why that essential bus is going to be right here. But basically these are all labeled for you. And then he also provides this orange cable, which is looped, so it's not broken. If you interrupt this signal, it turns off the wideband O2 sensing auto tune feature. So if you are running, let's say 100 low lead, and you foul that wideband, because face it, if we're going to do cross country, we're going to have to run 100 low lead in this at times. So if it fouled up that wideband sensor in the exhaust because of the lead fouling, it could start throwing pretty erroneous information back to the ECU, and you could kind of run a little off. Well, if you put a switch on this and you turn that switch so you interrupt this cable, it's going to turn off the wideband auto tune feature and then go back to the programmed map, which it runs just fine on just the map. That's actually the way the engine is set up from the factory. There is no auto tuning. So, and then your barometric sensing, or basically your air pressure, is going to compensate for altitude. So all the wideband O2 sensor is doing is fine-tuning the last 10% of that. And so if you are getting erroneous readings from that and it starts running odd, if you turn that off, then it will run just fine until that wideband O2 sensor can be replaced. So I'm going to power up the panel for the first time. I went ahead and connected the power, and I'm on the start screen. And I want you guys to be here for the removal of the plastic on the Horizon HX. There we go. Yeah, we're going to accept. A lot of stuff's not set up yet, so all the serial inputs need to be assigned. GPS is not going to pick up its position here inside the building. But here's your Horizon, here's the engine monitor, and then the iPad 11 backup system. But basically, power distribution to the panel is complete, guys. I'm pretty excited about that. Got a little bit more to do with the switches to set them up, and then all the lighting still needs to be wired, along with the fuel pump. So I think next is the fuel system. So we'll be moving on to that next. Just to run by the switches, if I haven't talked about them yet, this will be Master Avionics. This will be the iPad. These two were going to be the fuel pump, but that changed, so these are open. Probably be landing lights. Now I've got nav, strobe, and tail beacon, which will also be the transponder. This switch here, I needed a on-on switch, and they don't make these ones in that style, in an on-on. So basically what this one is it replaces the two fuel pumps, and this sends a signal to the ECU saying run the number 1 pump or run the number 2 pump. The ECU controls that pump, and if I get a light up here giving me a warning that the fuel pressure drops, I'll just switch it over and it will control the backup pump. So that's your fuel pump selector, basically. Over here, I think I went over this on the Autopilot, but that's Autopilot power. You can see there it's powered up. This will engage altitude, and this will engage heading, disengage altitude, disengage heading. So that's the Autopilot. I want to point out that building an airplane is a constant flow of UPS, FedEx, and USPS showing up at your house and delivering you awesome goodies that you want. And it's like Christmas every day. So to complete the electrical system on the airplane, I need a battery. And I think you guys know that this is the gold standard for batteries. And went ahead and got a EarthX battery. God, it's so lightweight. Yeah, so this is an ETX680C. This is the battery box that comes with the, or from EarthX. So I can actually come up high, or I was planning on mounting it down here, just above the engine mount. Basically, the power from the battery up to one side of the contactor and then over to the other side of the other contactor, and then the power from the contactor out to this bus bar and out from that one over to the other bus bar. So that's basically how the power distribution is going to be from this battery. And then of course the here's the rectifier or voltage regulator. It's going to come up and connect directly to the battery. All right guys, so let's weigh these up. So I've got 3 different batteries here. These 2 bigger ones were off of the Apex sleds that I have. I got a Super Start Platinum, which has 220 cold cranking amps. The Mighty Max, which is 200 cold cranking amps. And then the EarthX, which is 320 amps. So not only does it pack a bigger punch, but it's going to be lighter weight. So let's start with the big one here, the Super Starter. 9.5 pounds on that one. And the Mighty Max, it's a lot for the scale, 8.5, so a pound lighter at 8.5 pounds. And then the EarthX, 3.012, so 3 pounds on that. I picked up a charger, and basically it will maintain the battery. So if you go for a period of time where you're not flying, you put that sucker on there, and you're going to keep this thing maintained properly, and it'll last a long time. So more cold cranking amps, 5 pounds lighter than the lighter of these 2 batteries. Can't go wrong. So you guys, if you don't know about EarthX batteries, I don't know what cave you've been living in, but go check these out. And if you're going to be coming up on a battery and you don't need the weight of the battery for your CG, that is an awesome option to lighten up your airplane. So check them out. EarthX. Alright guys, I'm going to wrap this one up. You can check out this video from Alex DeSace's trip to Utah on the screen. I've got some more planning to do before I can move on, so I'm going to go ahead and sit down, plan out a little bit more of the wiring before I move forward, and we'll make that in the next video. So I'm going to crack a beer and get to planning.